Let's see what hackers are saying about this article, AI in Mathematics is Forcing Big Questions. I'm Dr. Samuel Allen Alexander, mathematician and philosopher, still here. At the top level, JDW64 says, someday human mathematicians might end up doing proofs for proofs. When a code base gets too large, you eventually can't understand all of it. Even code I wrote myself, I can't fully grasp. In those cases, we usually write tests. But when tests get too big, we end up writing tests for the tests. Eventually, it feels like we're heading into an era of proofs for proofs. For me, the problem usually unfolds like this. 1. I can't trust SDKs or Stack Overflow code. 2. So I write tests. 3. But I can't trust the tests either. 4. So I use test coverage, mutation testing, property testing, and fuzzing. 5. If that's still not enough, I add formal verification. 6. And then the problem comes, can I trust the verifier? That's how it ends up. Wouldn't human work shift towards verifying the verification systems themselves? For the mathematicians in the audience, you may or may not know what these tests JDW64 is talking about. In large professional code bases, people include so-called tests. Imagine that you're writing a piece of software and you make a change and you want to make sure that it works. So maybe you turn the software on and you try to do something, like you click on the box in the upper left and make sure that it glows blue when you click it or something like that. Well, rather than doing that manually, you make a robot do that for you. Make the robot load the software, click the box and see if it glows blue. And that is called a test. And you make hundreds, thousands of these in a large code base, maybe tens of thousands if it's a very large code base. These different things that the robot will do to make sure that when you made your change, nothing unexpected happened. Anyway, Bodzioni replies saying, interactive theorem provers are what verifies or proves the proof here. This means you don't even have to look at the actual proof to check its correctness. You just have to make sure the theorem definition is what you wanted. Not to say this is trivial, yeah, it often isn't, and that no nonsense axioms were defined, etc. Now, for verifying the theorem prover itself, this is kind of a chicken and the egg problem. We know the mathematical foundations are solid. Oh, well, yes and no. But to check the implementation of said foundations would require another theorem prover. In practice, most theorem provers try to make their kernel as small as possible so it can be reasoned about by humans. Coming back to the original topic, mathematics isn't all proofs, though. Someone has to come up with new theories and models. I guess this is what mathematicians would be doing in the future if AI becomes better at proving things than humans. But I could see it narrowing the field just like it's doing in others. Yes, that's right. Mathematics is not just all about proofs. In fact, oftentimes the proofs are just kind of a minor thing. In addition, a lot of the work is about narration and justifying and explaining why something is novel and so on and so forth. Anyway, let's go back to the top level. At the top level, FIFO RPG says, the use of computers in mathematics has been somewhat controversial from the very start. There are, of course, all the computer-assisted proofs, see four-color theorem, as well as the partially assisted ones, see Vyazovska et al. On packing problems in dimensions 8 and 24. But even finding a solution numerically, then rigorously verifying its properties, can leave a lingering sense of incompleteness, of a gap in understanding. I like this one quote by allegedly Wigner that illustrates it well. It is nice to know that the computer understands the problem, but I would like to understand the problem too. R. Dedev replies saying, reminded me of this quote, the problem with machine learning is that it's the machine that does the learning. Crystal Revenge also replies saying, but why should it be the case that that the human understands the problem too, is always possible? It's entirely reasonable that the set of useful mathematical proofs is a proper superset of human intelligible useful proofs. In fact, to argue the contrary would imply that there is something incredibly remarkable about human cognition. Well, yes, what Crystal is saying is absolutely 100% correct, but of course it doesn't invalidate the sentiment. Of course we would like to understand the problem, even if we acknowledge that we cannot possibly understand all problems. ZMG Sabst replies, saying, no, it doesn't imply that. Just that the set of proofs a human can interpret and the set of statements a human can understand overlap. Conversely, You require that the statements/theorems humans can understand be a larger class than the proofs they can understand. To me, it's not obvious which of those should be true. Can we only understand theorems for which we comprehend their proof? Or can we understand theorems despite not comprehending the proof structure? Within the mathematics community, opinions differ, but you're elevating your perspective on that question into a law without any evidence. That's kind of going off on a tangent. Replying again to FIFO RPG, Shmoo Blaster says, mathematics has always been an experimental science to some extent. While Newton, Euler, and Gauss would spend a lot of time calculating numerical approximations by hand, modern mathematicians have been doing the same thing using computers and software. And once a clear picture emerges about what's going on, you can start to formalize that and attempt to prove and communicate your results in the standard definition proposition lemma theorem scheme. But there is even a journal called Experimental Mathematics devoted to this approach. I don't see that AIs will fundamentally change this, but rather accelerate the speed of mathematical research. I agree with that, by the way. Some computer-generated proofs might, of course, be hard to understand, but at least their existence gives another data point to work with. Doing mathematics is more than proving something. It's just the end of a long road spent pondering at one's desk about how things could work out. I have never heard of this journal, Experimental Mathematics. That sounds very interesting. I might have to take a look at it. Slop in the Bag says, reminds me of a quote from Tsoding, and he quotes, programming is understanding. If you don't understand what you're doing, you are not programming, you are generating text. Perhaps a proof without understanding is just generating numbers. No K22 Cone replies saying, programming is also solving problems. In medicine, they use all kinds of drugs which they don't really understand how they work. Anesthetics is a great example. Let's go back to the top level. At the top level, Guyomes says, beyond the technical aspects, this new technology also leads to fundamental social changes. In particular, until now, mathematics were one of the rare sciences where great scientists could emerge from any country with a good education system. With the rise of strong AI tools, only scientists in rich countries with access to those tools might be able to advance faster on the most difficult problems like the Millennium Problems. Mathematics might become like experimental sciences, where you need to build expensive machines to make further progress, such as nuclear fusion. Actually, even now, the strongest models in mathematics are only available to a few engineers and a few mathematicians selected by OpenAI and Google. I would disagree strongly there. Guillaume is conflating things that involve calculation, such as large language models, with mathematics. No, mathematics is not calculation. And just because AIs work by doing tons and tons of matrix multiplication, that doesn't mean that it's mathematics. Aside from that nitpick, the idea that mathematics might degenerate, you could say, into something where you need expensive investments in order to work, that's kind of slightly horrifying to me. I hope that's not the case. But I sort of doubt it is the case. I could foresee a world where certain mathematics requires this expensive lab setup, but I would be surprised if all mathematics were to require it. Anyway, Dag100 replies saying, in response to mathematics were one of the rare sciences where great scientists can emerge from any country with a good education system, but would they be able to realize their potential without further, mostly monetary and institutional support from their country? In that way, things now are not so different from before. However, the story will probably change in a few years' time. Computational intelligence obviates the role of the human in making capital reproduce and multiply. Mathematics as its own field of study might become pointless other than as a hobby, an endeavor reserved for those entitled to the machine's output. What the machine develops in the place of mathematics may not be recognizable enough to even share the same label. That is, if it even uses mathematical principles rather than just finding correlations that are good enough for its use. This comment makes me think about Ramanujan. Ramanujan was a famous Indian mathematician. You've probably heard of him. He was a brilliant guy with strong mathematical intuition, and it's a very good question whether AI would ever be able to replicate him. Anyway, the reason I bring him up is because the amount of money that was had to be spent for him to do his work, it would be totally trivial. He had to be flown to England, although even that shouldn't have been strictly necessary, but he was flown to England and fed and boarded. But this is quite trivial costs. At the top level, Glowbug says, turns out you have to be Terence Tao to know when an AI is right or wrong. No. That's a total non sequitur. Absolutely incorrect. Gardez J says, quoting someone, I imagine my work could be completed with AI assistance in a matter of days, maybe hours. Would someone with tokens to burn mind checking that statement out and post back? Be sure to use long dashes too. Silly sort of joke. This seems to be going off on a tangent. At the top level, Rirza says, I think we're going to find out the hard way that the proofs left to solve are very much not elegant. And String Food replies saying, couldn't God have created a more orderly universe for us? This is ridiculous. Stroganoff says, to assume that the universe is disorderly presumes knowing some esoteric objective truth about how the universe works. Since the field of natural sciences does not provide that truth by design, and practices that do aim to provide that truth, metaphysics, religion, etc., seem to have different versions of it, I would say that there's a fair chance that the universe is not that disorderly when we just lack better models for describing it. That squares with my intuition as well. I've always found a frequently recurring pattern is I'll have some idea, some theory, I'll be really excited about it, and then I'll discover that I was wrong. It doesn't work. And my hopes are dashed. I feel terrible. But then, later, I'll figure out how to fix it, and then once fixed, it's even more beautiful than the original theory. And I think that is sort of, well, I conjecture that that's some sort of cosmic universal law of how the truth of the universe works. If it seems super complicated and ugly, it just means we're not looking at it right. We haven't seen it through the correct lens yet. Vertex says, the way I look at it, the absurd complexity that rule systems can get into is a check and punishment for the arrogant and the tyrannical. Look, I designed these rules myself, just follow them and everything will be fine. Ah, but what about this edge case? I guess we can add a few more rules. Bam, next thing you know, it's a Byzantine bureaucratic nightmare, and your empires refuse to grow anymore. Meanwhile, if you put honorable people in charge and trust them to do the right thing, they can figure things out ad hoc. Unfortunately, mathematics suffers as a bystander. But the good news is that the muggles will always want to keep the eggheads around because they would rather die than think about the negative consequences of having their dreams come true exactly like they wanted. Strange sort of comment there. Pretty much all of mainstream mathematics can be done using ZFC, which is only a very small set of rules and not too complicated, so I'm not sure what this guy's talking about. Anyway, that's enough of this thread for now. I'm Dr. Samuel Allen Alexander. Please like, comment, and subscribe. I'll see you in the next video.